Hello, hello, and good morning or good afternoon. It depends on where you are. I'm Ettore Volpicelli. I'm in charge of marketing for developers in Oracle, taking care of our special community that support us and our customer to perform in their daily business. So here today, we are working on something that has this feeling of summer, Json and soda, let's say. Today, we have two great specialists on this topic, Beda Hammerschmidt and Roger Ford. They will drive you into this hands-on lab. So you will have both possibility, the one to just follow Beda into the lab, like a walkthrough, let's say. But our suggestion is to perform the lab yourself. So we distributed into the reminder email the links to get a free tier account if you don't own already an Oracle Cloud account, plus the lab guide of today event. We will share soon this also via chat. And I think that now is the moment, Beda, that you take control. Enjoy the time that you are spending with us. Thank you so much. See you later.
Hey everyone, and thanks Ettore for the great introduction. Also thanks to Roger Ford, who's also there to help you out. Yes, so this is a live lab. So there are a lot of instructions on the web page that you follow to understand what's possible with JSON and with our simple document API called Soda. And I suggest that you now, if you haven't done so, sign up to get an always free account for the Oracle Cloud. So there is this link here that I believe has also been added to the chat by Ettore. So just sign up now. And you have been whitelisted, meaning that it should be really easy to sign up, really streamlined. And then please go to this lab and with the Oracle Cloud, deploy a always free database. So everything you do today is not only do you get credits, you don't even need the credits because we are doing everything with an always free tier database. And always free really means it stays free forever. So you can come back months later and still work with your database. Good. So with this, what's the agenda of today? As Ettore said, it will be a lab, but before we go in the lab, I will talk a little bit about using JSON as a data model for development. So this is the part that you can listen now to me for a couple of minutes while you are signing up for cloud and setting up your database. And the sign up is the link, and the second link gives you to the lab, and the lab has an instructions on how to get your hands on an Oracle always free autonomous JSON database. So there's screenshots, instructions. It's really, really easy. Good. So let's say we want to build an application. We were now in lockdown and we said, hey, let's write a little application on the side and let's write something like an online shop where we want to sell some of these used books and movies, etc., that we have in our house and that we don't watch or read anymore. And we want to really make this just a small application, nothing where we want to do a schema design or normalization for a long time, just a quick app, just see how it goes, our own online shop. And we start out with books and movies, and maybe in the future, if our shop takes off, we're going to sell more items that we don't know of, maybe posters or postcards, whatever. And there are some properties for these items that are that are true for every item. Like every item we sell has a title and a price and maybe a condition because these are used items. And then there's a type, whether it's a book or a movie. But then on a book, you have additional other properties, like a book, for example, has an author and it's written in one language. Whereas for a movie, you may have a format. Is this a DVD or is this a Blu-ray? Let's say people are interested in actors, so we have a list of actor names there. And typically a DVD, you can switch to multiple languages. So in contrary to the book, you don't have one language, but multiple languages. And we start, so we're application developers. We don't really start down at the database. We start with our application. So we come up with some classes here in Java. Let's say we write this in Java. So we create a superclass product, which has all these shared members or properties. And then we extend it with subclasses to provide all the attributes for the or the attributes that only apply for one specific product, like the movie has a list of actors. Right, so everything's super easy. And now we want to look at how you would do this relationally versus JSON. So this is a little bit to motivate why JSON-based development is really a big time saver. And what we see here is if we wanted to normalize it, what looked so simple on the previous slide is now already quite complex because we have to create various tables. I think it's 7 here. And there are these joins or these references across. If we just look, for example, at movies, so a movie typically has multiple actors, and actors typically play in multiple movies. So there is this, what we call this N-to-M relationship, and we need an additional table just to reflect that mapping here. And now, before we can even insert our first product, let's say our first movie or book, we have to create all these tables. We have to list the columns with their data types, any foreign key, primary keys. So even before we could insert any data, it's already quite involved to create the right schema. Whereas on JSON, now this is on the right side, there is a concept of working with JSON collections. And a JSON collection does not have a schema. It's being defined by a name. So think of a collection as being a bag of JSON documents or of JSON data. And here we create a collection called products. And no schema design, so it's a lot easier. Now let's say we want to insert a movie. And now on our relational side here on the left side, what could happen is that it's a new movie, but one or multiple of the actors are already existing in our database. So we would have to query our actors table to see whether all the actors are new or whether some actors are already in the database. And depending on that, we either have to also add the information on the actor or just link existing actors up to the new movie. So this is why I said SQL magic here, because it's really not so trivial just to insert a new movie. And again, if we look at the JSON way of doing this, you see we're now inserting this JSON document inside our products collection. And you see that all the information is in line. For example, this actors, we just have an array of actor names. So there's not this problem of looking up actors in a separate table. And this is the key difference that you need, or that you want to understand, that with JSON, we're basically embedding this information. So all the information is inlined. Whereas on the relational world, you have links between different tables that express that one row in one table is being used in another table. So it's really linking in relational versus embedding in JSON. So now let's look at the query side of things. Let's say we want to find all the movies where Jonah Hill is an actor in. So now in order to find these movies in this relational schema, we would have to join 4 different tables, our products tables, movies tables, actors table, etc. There's some join condition, and then we pull out all the attributes that we're interested in from these various tables in order to rebuild our movie object that matches the search criteria. Whereas with these collections, there are simple filter expressions or query expression. We call them query by example because this is a part of the JSON that we are matching against these documents. And this is what you will see a lot in the workshop. So, and I will explain it there here. I'm skipping this a bit, and we're going to see how this works in a second. And it works. Good. So another aspect, and I'm hoping you're still signing up for cloud or getting your database at the moment while you listen to me, because in a couple of seconds, we're going to jump to the workshop. And by then, I hope you can follow what I do. Another common thing that happens is if we start out with an application, we may not have understood the domain entirely correctly. So we may have to make changes. And the changes we need to make here is that we say, oh, people may be looking, or they may want to know when a movie was released. They may be interested in movies from the 80s or 70s. So we need to add an additional attribute. And we made one more mistake that I don't have it on the slide here, but basically we have to realize that a book could have multiple authors. Oh, I think it's coming in a second. So basically here, in our relational, adding a single attribute, it's easy, it's just another column, but it is a schema change, whereas in JSON, there is no schema, so all I do is I add a new attribute. So this kind of schema change is a bit tricky relationally, but not too hard overall, but very trivial. In JSON, I just add another attribute. But let's say there is another schema change, and this is a cardinality change. So we thought a book always has one author, but some books have multiple authors. So now instead of having one author string, we have a list of strings. And now this is a lot more complex to make or to adopt a schema in the relational case, because now we need a similar mapping table, end-to-end mapping table between our authors and books. So it's kind of similar to, or exactly the same as with the movies. And this would apply that, what do I do with my existing data? I have to move it now into these two additional tables. I have to change my insert statements, my queries, etc. So this is quite a drastic schema change or application change here. Whereas in JSON, all I do is in my new documents or in those documents that have more than one author, instead of pointing to a JSON scalar value, I now point to an array of scalar values. So you see here, author points to an array of these three strings. And the nice part is that I don't even have to change my query. So here you see I'm looking for author J.K. Rowling, and this is actually matched against each item of the array. So that is quite easy. Good. So now the impression may be, well, I'm only doing JSON from now on, no more tables. So that is what you could be thinking now, but there are some limitations in JSON data model that you also need to know. So I really want you to understand everything about developing with JSON and being able to understand when it's better to, let's say, use JSON, when it's better to use table, or what the purpose of this lab is, kind of combine the benefits of both. So now one thing is, let's say instead of having actors just the names, let's say we have some additional properties for the actors, for example, when they were born. And now you have to repeat this in every occurrence of this actor, because we are embedding information. We are not linking information. In the relational case, you would add, let's say, an attribute to your actors table, and everyone who links to it would get the same information. You would not have to repeat it. Whereas in JSON, because of this embedding, you need to repeat this information. That's already, repetition is not so nice, but it's actually getting a bit more complicated. If you do updates, now you don't have to update a single occurrence, but you have to update all the occurrence. So if, for example, you were using a NoSQL database that doesn't have real transaction, then at this point you could end up with inconsistencies. Good. There's also one thing where this entire business of embedding really has its limits. So we were saying we wanted to do an online shop. So an online shop has more than just products. It has customers, it has orders, etc. So here we are embedding everything in one JSON. So some JSON databases, especially NoSQL databases, kind of go this route where they say, oh, we don't have joins, so we need to embed everything. But at the end, what you would be doing here is embedding a lot of different entities. So you would say, I have just one document, it has the order information. So let's say this is for an order. Then it would have to repeat all the fields of your customers instead of just saying this is customer ID 123. And then you have your orders, your line items, and there you have to repeat all your data again. So this is just not working. This is kind of taking JSON or too much JSON and taking this embedding business too far. So the reality is here you have different entities. And even if you want to work with JSON, you don't want to mix these entities. So you're still having different entities, and the recommendation would be to store them in separate collections. And then even you would need joins across these collections, for example, to say, I want to see who this customer is. And this is a big reason to use a relational database with JSON support, like the Oracle database, because there you do have the ability to join across collections, and therefore you don't need to mix these different entities. Good. Another benefit really of the relational model is that it's very good for analytical queries and reporting. So let's say you wanted to find out all your, like what are my best selling items per zip code, for example. So in order to run such a query, you would have to look at your purchase orders to find all the items that were sold. And you have to look at the customers to get their zip code. So I'm not going exactly through this query, but the message is that in this relational model, there is not a single point of entry like with JSON. JSON is a hierarchy, so it's like a tree-like data structure. You always start from the top, whereas with a relational model, you basically drive your query from any table. So let's say you had a query on just actors, then you could directly query the actors table. You wouldn't have to drill through your products to find the actors, for example. And this is also something we're going to show in the workshop, how you can do relational queries or how you can map your JSON data to a table format and then run queries over that relational format. Good. That's the question. Is JSON and tables, is this an either or decision? And the reality, it is not if you use the Oracle database, which allows you to combine the best of relational concepts, let's say joins, transactions, etc. And you can store even relational data alongside of JSON data. And with this, we go to our lab here. Let me share a different screen. New share. Okay, so I hope you can see this now. This is the workshop, and I hope that you have signed up with the cloud and that you got a database. And now here, there is, if we go over this, there is a video, you can watch this later. And there's also an introduction into JSON. So for those of you that have not worked with JSON a lot, it may make sense to read this. So we basically we represent our information in these key value pairs. It's quite easy. I'm not going through this at the moment, but there is a description on JSON in here. And in this workshop, what you basically learn is the fundamental of this JSON data model and when to use it. I kind of covered that already in my previous speech here. And we're going to look at how you're going to work with JSON documents using a document store API. This is called SODA. That's short for Simple Oracle Document Access. But we will also show you how you can run SQL for or on the same data. So you can use both a simple API as well as SQL to access the same data. And we're also going to cover how you can generate new JSON data. Good. So with this, there's this getting started part. This is where you sign up for your cloud. And I'm asking you if there are any problems with signing up, just put your question in the Q&A or just contact Ettore in the chat and he can help you out signing up with Oracle Cloud. And the next step is to sign up for the Autonomous JSON Database Cloud Service. So there are screenshots here and I hope you followed them. And what you should be seeing at the end is a welcoming screen like this. So for example, here it's telling me I'm always using this always free tier account. So I basically use the same service that you are using here. So I'm closing this now. And then on the left side, you should see Oracle databases and the autonomous JSON. And you should see a cloud service. So I have created two databases here. This is a 19C, which I will be using for this lab, but you should also be able to use a 21C. So on that note, so let's go back quickly here. So we do have different cloud databases. So for example, what you see here at the bottom, so this is a terminated service. Because I'm using an always free tier, I can use 2 different databases. So it's not one, it's actually 2 that I can be using in the always free tier. And I chose an autonomous JSON database 21C, and this with this odd name, it's like a 19C. I forgot to give a more user-friendly name. And up until yesterday, I also used an autonomous transaction processing database. So what's the difference between the services? There's also a data warehouse cloud service that is optimized for analytical and data warehouse queries. All of them support JSON, but we're more looking at a operational store. And this is why we look at autonomous JSON or at autonomous transaction processing. So autonomous JSON is basically, it's a regular Oracle database, very similar to autonomous transaction processing. Actually, I think if you use the always free tier, they're pretty much the same. It's only if you are upgrading to a paid account then autonomous JSON is a lot cheaper than autonomous transaction processing. And the only caveat or limit is that you can't store more than 20 gigabyte of non-JSON data. So it's not about the amount of data you store as JSON, but since this even autonomous JSON is a regular database, you can create normal tables without any JSON, but those would be limited to 20 gigabyte of storage. So you could even pick an ATP, or if you already have an ATP database, you could use that for the lab as well. But here we're using autonomous JSON. So this is where I get my 19C database. And the next steps, I think, are to explain these database actions. So these are the interfaces that we're using. Ettore, do you get any feedback of people having problems signing up, or do you think by now most people are good?
No, I'm not.
Yeah,
you can go ahead, because I had an issue just with one attendee, with one participant, and we are handling that. No other major stuff.
Got it. So by this point, we want you to basically have a similar screen where you have an autonomous JSON database, and it says available. So this from starting a new database to it being available, it takes about like 2-3 minutes. And if you're not here yet, just shout out in the chat or Q&A, and then we can wait a little longer. But basically, if you're here, click on tools and you see these database actions. And database actions basically means these are user interfaces that we're going to use here. So I need to log in. This is the admin user we're using. Should have been uppercase, but now I'm here. Let me make this a little bigger. And there are different tiles here. And I suggest you right click on those and you open the SQL one and you right click and you use the JSON one. So JSON means we're looking at the same data. These are just different ways to access the same data. And here with JSON, we get a document API over it, where we work with collections and JSON documents inside the collections. And with SQL, I have a normal SQL. So here I could write any create table, select, etc. SQL developer web. Okay, and let's look at this is now the lab 2. So lab 1 was just provisioning, get access to a database. And now the first step is to actually create a collection. So if we go to our JSON workshop, there's actually like a little helper here that gives you like a tour. You can either do that or you can just skip it, because I will explain it anyway. So what we can do is here it says create collection. You could also click on this button here. If you already have a collection, it wouldn't show this. So this would be the screen where you say, I want to create a collection. Now there is a lot of information. It's all grayed out, and that is fine, because all we want to do is create a collection called products here. So the collection really only has a name. Good. So now we see here we have our collection products, and I will explain these different windows in a second, but the next step of the lab after you created your collection is to insert a document. And initially, we will just insert documents just by copying them into the window. We're doing a bulk up insert a little later. So now let's copy this, and you can either mark it and copy it with Control-C or just click copy. And the way you insert a single document is you click here, new JSON document, and you insert it, create, and then you see a little confirmation window here, which means the JSON document got inserted. And you also see the contents of your collection at the bottom. So there is one document in here. Let's just repeat this. And you see everything here is described with a lot of screenshots. So let's just copy. Let's just insert a bit more. And there's another one. Create. And I think this is the last one initially. So then we have 4 documents here. So I think the first 3 are movies, and this one is a book. Now what I see here is all the documents, and there are symbols here where I could edit them or remove them. But we want to look at, I believe, the query aspect, basically finding documents that are inside the collection. And this is where we use these filter expressions. So what you see here is already a filter expression. It's an empty JSON object, and this means select everything. It's kind of a select star, but I could say, well, I want to find all the documents that are matching to this pattern or filter. And we could say one thing is, well, let's say, I think what's in the doc is looking for an ID. So let's say we want to look for ID 100. So now what's happening is this, what does this filter expression mean, or this query by example mean? It means find all the documents which have a field ID and where the value of ID is 100. So if I run this, I only get one document being returned, and this is the one with ID 100. I could go back and just empty it out, and I see all my documents again. Another example would be to look on the format, everything where the format is DVD. So I could filter on any field here, and I can also use negation. And the syntax here of these query expressions is always JSON itself. This is why you won't see greater, smaller, equal symbols. And instead, there are these commands starting with $. So basically it means find me all the object which have a field type, and type must be not equals to movies. And I think in this case, all it returns us is the book, because the book is not a movie. So it's relatively easy to use this. So there are a few more examples. I'm not copying them here. So this is how we can do a like with a match, everything where the condition contains the word like. Or if I want to do a numeric comparison with less than or equals, I can look for all the items where the price is less or equals to 5. And I can even combine them. So let's just copy this one here and explain this. So again, the query expression has to be JSON. This is why it looks a little bit cryptic. So I'm saying there is multiple conditions and they must all be true. So the condition is an and the conditions itself are listed in an array. So it could be more than one or more than two. In this case, there are just two. So one condition is that the price is less than or equal to 5 and the type is a movie. So then this gives us the two movies where once the price is 2.5 and here it's a 5. And I guess if I remove the E here, then it would be true less than 5, and then one movie where the price was 5 is getting removed. So yeah, you can play with this. This workshop does not list all possible query operators. There is a bunch more. And you can look at our documentation. It's the JSON developer guide and the SODA documentation that documents all these possible QBEs here. Good, but this is a way how you can very easily find documents inside your collection based on some properties that the documents must satisfy. Good, and with this, we're going to already combine a little bit of relational concepts here. So what I'm doing now is let's go back here to my empty query pattern. Ettore, any feedback so far? Are people fine? Anything I need to explain, or I'm good to go? Continue?
You can continue.
Okay.
Hey, we had one question saying,
yes.
Can I use query by example in my own code? So you might want to answer that.
Oh, yeah,
benefit.
perfect. Yeah, I missed that. That's an excellent question here. Yes. Oh, yeah, very important. I'm showing you here. So the purpose of this lab is that you do not need to install anything. So everything you do in this lab, you can do in always free tier. There are, though, obviously, if you write your application code, you would want to use these expression and this API, these simple puts and gets directly from your programming language. And this is where we have SODA drivers. So again, SODA is the name of this API, Simple Oracle Document Access, and you get support for drivers in Java, JavaScript, Python, REST, etc. So we're going to use the REST driver a little later, but yeah, you would write exactly these path expressions directly in your programming language. Exactly, yes. And Roger, maybe you could look for a link where I think we have like a SODA where all these language drivers are, like a SODA starting page. Maybe you could put that in the chat so people know where to get started if they.
Sure, I'll do that.
Awesome. Yeah, great question. I missed that totally. Very important information. So now one thing is that we said JSON has no schema. And what I could be doing is I could be inserting data where the ID is already existing. I just, or hold on, this I think was not the document. This was the query. This was the one I am inserting here. So let's say I'm now inserting a new document. And the point is the ID is already in use. So basically we use the ID already for the movie Coming to America. And now we insert another document. And there is nothing stopping us from doing this because JSON is schemaless and we have not told the system that the field ID has any special meaning. So it's just one key value pair. So now if this was our product database, we had a problem because there are now two different products with the same ID. So that is something we would want to prevent. So what I do now first is I erase this one. And this is something where this is a little odd. Are you want to show to delete this? This is an internal ID. There is probably something we need to improve this a little bit, but to show what you're actually deleting and not the internal ID. We're going to do is we are going to use so there will be an indexing. So right now I can't create search index, but for now there is no user interface to create an index in this console. So I'm going to my SQL developer web interface. And now if I look at all my tables, I see that our collection product is actually a table here. So I see that there is a products table. So now I could say select star from products. And the same data is accessible as from a SQL point of view, and you see these internal IDs being used. So those are not the IDs we're using. There's some metadata when it was created. And then there is a column JSON document, and all we see here, it's stored as a blob. If I would run this on a 21C database, it would actually be a JSON type. So that's the difference between 19C and 21C, that there we use JSON type, and JSON type is a new addition which was not available in 19C. This is why 19C uses blob. So, but I can't look inside, but I can use an operator to convert this into a string. So if I run this, then we should be seeing our values here. And I'm now using this SQL access to create an index. And this is, as I said, where we're going to have a UI for eventually, but for now, we're going to use the SQL interface. So I'm creating a unique index, and I call it the product ID index on my products table, which is also the collection. And I'm using a Sql Json function. And we're going to cover that later in the lab to extract this ID field as a number. And this error on error means whenever there is something not matching, like whenever it is not a number, for example, then raise me that as an error, and that will prevent inserting this document. So I'm just clicking here on start, and I see this index was created. Now I can go back to my SQL developer, and let's insert our banana again. And if everything works, then we should not be able to insert it. Let's see if this goes, create. And now you see there is an error, unable to add new JSON document. The unique constraint was violated. So this is our first example of how you can combine things from the relational world, like constraints. We're gonna actually, let's, I think the next step already does that. So let's go to the next one. So we created the unique index. Exactly. So, oh, this is another example here. This insert should also fail. So now I'm creating a new document for the movie Top Gun. I give it an ID value, but the value is a string. It's not a number. This would also fail because it's not a number. So this really prevents me of inserting wrong data. And now we want to do another check constraint here, another example of leveraging relational constructs with JSON. And this is a check constraint. So what I want to do is I want to make sure that every product I enter as a minimum has a title, and the title better be a string. And I wanted to have a price, which is a number greater than 0. So here I'm not using an index to enforce that. The index also helps me to look up products by ID. It's quite likely that I will have more product in the future. So I created this index, this product ID index, also to do fast lookups. But here, this is not an index. This is a constraint or something that needs to be validated here. So what I'm doing is I'm altering my products table. I'm adding this constraint. I call it required fields, and I want this to check a condition, and the condition must evaluate to true. And the condition is a JSON check, where a JSON exists, and it's checking that all my titles. So this is the input, this is this JSON document, and then we have this path expression, and we're going to cover path expression 2 in this lab, but here it's already kind of a little ahead. We say, okay, I want this condition to be true, and this is the title must be of type string. So I'm not saying anything about the value, etc. I'm just saying it has to be like a string, and the price must be convertible to a number and then greater than 0. So now if I run this, I see that this check constraint has been added. And now what's the data we want to insert? So we want to insert our Top Gun movie. So now we corrected this. It now has an ID, and I guess it's also unique. It has a title, which is a string, but it does not have a price. So this is why you say, hey, I'm not going to insert this record because it does not have all the required fields here. So this allows me to really enforce some conditions on the data that I'm inserting. So this is now a correct document where I basically say, let me close this. So it has an ID, it's unique, title, and it has a price. So then you see this JSON document was created. Good. So this is an example of how you combine relational concept like indexes, check constraints, unique indexes, etc., with the with JSON data. And all that obviously can be done from your programming language. Good. Any questions so far here, Ettore or Roger?
Yeah, there's one interesting one. I
Yes.
wanted to ask how to select a subset of a JSON document. Is
Yeah,
there such a command?
There is. It would be here in lab 4 when we look at JSON query, I guess. So we'll hopefully get there. So that is possible. I don't think it's possible at the moment using this interface here. So this is again where we would go to SQL. But let's go to REST for a second. So I already said you have different drivers that are supported. And one of them is like REST, which is programming language independent. So one thing you can do here is if you look at this, what you have in your address line here, the URL, you can actually copy this and you can remove everything after admin. And I believe you can just write soda latest. Let's see if this works. Exactly. So now I'm making a REST call to the same soda collection, or actually not, I'm not making to all my collection. I'm basically now asking this API to list all the collections. So it's now telling me this is your products collection, and then some information on how it stores the JSON. So it says I'm storing it in a column JSON document. The type or the SQL type is a blob. The format is actually OSIN. This is our binary format, so on. And then I can just append products here. And what I get back is now the content of this product collection. So you see all the movies we inserted, which was the last one, like Top Gun, I believe. You see this is now being returned from a REST call. And what I'm doing here is a GET request. So the browser, whenever you load a URL, that's a GET. But in order to do some operations here, we need to also do some PUT requests. So you can use Postman, or you can use the cloud shell that we have in Oracle to make these requests using the curl command. And this is what I'm showing how to do this. So if you go back to this page here, there is this symbol cloud shell. So what basically, let's say how would you get there? Probably if you have this screen, you probably go to, so this is database actions. So this is why I use the right click to get back. Log out, sign out. Yeah, you may need to basically start this login process again to get on this page. And what you see here, like next to your region, is you see this cloud shell. And if you click on it, it will open this black window at the bottom. And this is a shell. It may take a bit longer for you if you start this the first time. So for me, it only took like a second, but normally it takes a bit longer if you start it the first time. Then you can do things like ls, or I'm removing a document now called test data JSON. And I'm going to make these REST calls from here. And you can choose to make these REST calls. If you have a REST program like Postman, you can do it from there as well. It makes no difference. Good. But what I really need is this prefix here. I need that part here will be different for every participant. So you need to take a copy, and then you could copy it somewhere in an editor, and then you could take it from there. This is what I'm doing at the moment on my second screen here, and I'm going to move it on the main screen. But let's go back to this lab. So what we do is, Now, this is the URL. I've already shown you this in the web browser, so you can make direct access using GET request. But in order to do puts, we need to use this Cloud Shell. Good. So here it says your URL, and now I'm going to show you how we do this. So this was my URL here, and the part that is before ords admin soda, so this is basically like the prefix, and that's called your URL. Okay, so I'm going to use this, and now what I can do is I can, I could do a curl get. I could do that directly. So let's say I'm just now appending this again. Then we see this products here, and I'm doing what do they call it? Curl x get. Okay, so I'm edited it here in a notepad window, and then I go back to my Cloud Shell here. I'm copying it there. And then it says not authorized. Okay, so I missed something. It's not authorized. And what I missed, and you may miss it too, is that there is a security feature enabled by default. And this prevents anyone to kind of just load data from your website. So we need to disable that for a second. So this is here in step 8. Exactly. So there's this authorization error. This is our security mechanisms. The REST request came from outside that database cloud service. And so there are ways to authenticate, but before we go there, because there's that many ways of authentication, we will just disable this security checking. So you wouldn't do that in production, but this is the command here, the privilege mapping disabled. So I again go to my SQL Developer Web, and I just execute this command here, and we see procedure successfully executed. And now if I run this again, then I see not as nicely printed as in the web browser, but you see Top Gun is here. So this is the same response as it was returned from this stuff. So I made a GET request here. Good. So now what we do is to we could issue a QBE, for example. So this is, again, let's go to this editor. How would I issue a QBE? So the QBE is the price greater than 5. This is the filter expression. And my URL is this, actually without this one here. So I'm doing a copy replace. Now, and you see this is a post request. This is why I use this in curl and not in the web browser, because the web browser makes GET requests, but I want to make a post. And I could not resolve HTTPS. That's what was going on there. Oh yeah, I copied a bit too much. Yeah, there are quite a few. Exactly. So now what we see is all the items where the price is greater than 5 or so. And you see here 9.5, that seems to be matching. It's a bit hard to read, but what we did here is we appended this action equals query to our URL, meaning we want to run a query. And the query itself was the payload of this post request. So this was the query by example expression that we would otherwise have put in here. And instead of making or putting it here in the user interface, I just placed it here in this curl post call. Good. So you see that these all these soda operations are also possible in REST, and we may have labs in the future showing how you use this in Java or Python and JavaScript, etc. But for now, this has to do it. So you see the we can also insert. Yeah, let's do an insert here. this is also interesting. So again, I'm copying this, and okay, so the URL does not contain the HTTPS. And now I think I got it. This is my URL. So I'm replacing just this part. And I'm inserting a new product with the ID 1414. And you see the insert has just the URL name, so there is no action equal insert, but it's basically the post without any additional URL tells that this is an insert. So what I get back is some results on the E tag. This is like a hash that's been generated, the data when it was motivated. So I basically get some feedback on the insertion being successful with some information that, for example, I could use in a cache. So now here, the ID was 1414. So let's see if the insert was successful. And you see we inserted this new JSON document. It's actually a new type. So we only had books and movies so far, but now we have a toy that we want to sell for 50 euros or dollars. And this also shows the schema flexible part of this of JSON, that I can just add new types or make schema changes as I go. The check validation would still be validated. So if I would make a curl insert here with a price that was not a number or ID not being unique, then I would receive an error. Let's see if we can, I mean, we could try this just live here. Let's say we use ID 100, which I believe exists. So let's just remove all that stuff. Okay. And so this is not in the lab. I'm just curious here. And yeah, you see there was an error. So what I get back is a 400. And I also get a description that the unique constraint was violated. And this was the unique constraint on the ID. So yes, the database prevents me from inserting bad data through all these channels. Good. There's one more thing that is important here, which is to insert more data. So what we did to like have it easier to test more data or to insert more data is we uploaded a JSON to our object store. And I'm doing now, so this is something you can just copy because this is a pre-authorized list linked to the JSON. So I'm doing an ls now. You see there's only one thing called A. I'm running now this curl request, and it's now downloading a JSON data from the object store. And I want to use this to do a bulk insert to my products collection. So this is actually a JSON array with a couple of movies, I guess. And what I do is I'm using a soda operation. And what I do is an insert. So here, so insert is basically a bulk insert. So this is what it says. So I'm uploading testdata.json, which I first downloaded from the object store, and I'm now uploading or using this for a bulk insert to my soda collection. So my URL is this. And where's my Cloud Console? It's here. Let's run this. Okay, I get some feedback. And now if I just do a reload, I should be seeing a lot more movies that I have not seen before. So this makes it then more fun to you to look for your favorite movie or to look for, try out these QBEs, because now you have more documents to query. And you also see that, for example, there's like new fields like genres or who are acting in these movies, etc. Good. So now we have more data, and now we can go to the next part of the lab here. Any feedback so far, Ettore or Roger?
Roger is actually answering many questions,
Yeah.
and now there is one that is pending. How can we configure orgs to all course policy.
Oh, what is course
Yeah,
policy?
I think this is probably an ORDS question rather than a SODA question.
Yeah.
It's cross-origin resource sharing. It appears to be some sort of security setting to allow access to other websites from a request. I think that's probably beyond anything we can answer here. We'd need to follow up later on that one.
Yeah, we could ask Jeff Smith this, or we can get back to you, or you just tweet Jeff Smith. He's usually very responsive. So all this here, the SODA API and this interface makes use of ORDS, Oracle REST Data Services. And there are many ways to dealing with security and authorization, authentication. And we're kind of inside or piggybacking on that feature. So whatever is possible with ORDS should also be working with SODA. This is why I skipped this part when I said disabled security, because that's kind of an Oracle REST Data Service topic. And that's better covered by someone from ORDS. Good. So this is now where this lab leaves the world of these SODA or this SODA interface. We're going to continue to work with the very same data, but we're now using the SQL way of accessing it. So I had already explained that our collection is a table. It's also a table, or it is a table, which means I can access this table using SODA. Then all the table mechanisms are being like abstracted away or hidden from me. So for example, if I do an insert here or a SODA put, that's at the end, it's an insert to the table. Or if I run a query in this window, this filter expression, then this is at the end is select on the query, but I don't see any of the underlying SQL that is getting executed. But it is actually a SQL statement that gets executed. And the benefit of that is that any index can be used, or the optimizer can choose a good execution plan. And now we go directly to SQL. And I've already mentioned this Json Serialize. So this is a way to convert our binary JSON data back to a JSON string. So we don't store this data as a string for performance reasons. And also we have like a richer type system inside, but you can always turn it into a string by using this Json Serialize function. And now you see that the information looks like a string, and without the Json Serialize, it would not print it that way. Good. So now we could also use queries, which directly access fields inside the JSON. So here I'm using this Json Serialize, and I use the Json Serialize to turn my result back into a JSON, but then you see I have some conditions here in the where clause. So I'm saying where, so my table is called P, and the column that stores the JSON is called JSON document. And now here I'm saying that I want my P JSON document type to be a movie. And I think I could remove this string here on a 19C. Let's see if this is working. It should be working on 19C. And then I will explain in a second why you need these trailing functions in a 21C database. Okay, so you see, I just removed this type and this string function here, these called trailing function on my path expression. So I'm saying where the type is movie, the format is DVD, and where the price is greater than 5. And here I'm putting on a number to convert the price to a number to do this greater comparison in the number domain and not in the string domain. Good. And yeah, you see this is possible, simple way to access the data. I could also use square bracket if this was an array. So there is very simple way to access the data. Now I want to quickly run the same example on 21C. So I'm just looking at my other database here, and I'm starting my logging in. To SQL already pre-populated this here. Now I'm taking this same query that ran successfully on 19C. I'm taking this to my 21C database. And there I will see an error, and it says invalid comparison operation involving JSON type value. So this looks odd, so let me explain this. So what this means is that we are storing, actually let's do a describe on the products first. I do a describe products, and let's see what this gives us. And see the difference here, we're storing the JSON document as our new binary or our new SQL data type JSON. Under the cover, it uses the same storage model. So on the 19C, it would say a blob, but the bytes that are being stored are the same. So there is not a big difference, or not a difference at all in terms of performance, etc. But here we're using a JSON data type. And whenever you extract something from a JSON data type, like here, for example, the field format, that is a JSON value itself. So you extract fragments from JSON. These fragments could be nested object, nested arrays, or even scalar values. And then if you want to compare it with a SQL value, you have to convert it to a SQL value to do a proper conversion. This is why you have to put this string trailing function on there. So you're basically saying, take this JSON value, the type, the format, the price, and convert it to a SQL type before you do the comparison. So this is now how the query has to be different in 21C. So we can, let's go back now to our 19C database. I'm closing this now. So I can run the very same query here. So I can tell it to do a string. The only difference is on 19C, the string is kind of the default. It's returning a varchar value. So this is why you don't have to tell it. You could omit it. Yeah, that's the main difference between working in 21C and 19C. I guess it's good practice to add these things even on a 19C, because you don't know, you may upgrade to 21C and then you want to have it right from the beginning. Good. So this is just like a simple way to filter your data based on this dot notation. And it's also possible to extract things directly in the select clause. So what I'm doing here, instead of using Json Serialize, I am using the same dot notation or the same way to extract fragments in the select list. So I'm saying JSON document, title, and convert this to a string, and the document or the year to a number. And there's also a where clause. I'm only interested in the movies, and I want to order it by the year. So I want the newest movies on top. I don't know why it's putting like the comma there. Maybe because, oh yeah, because it's a number. So it's treating this like a number 2017. But you see, this is the movies from old, from new to old. Good. So yes, so another interesting thing, obviously, if we have SQL access to the data, we can very easily do analytical queries. So what I'm doing here is I want to find out, so there is a field called decade in my data. Let's take a look at it. So every movie has a decade where it belongs to based on the year when it was published. So like Django Unchained is from 2010, and then there's like movies from the 80s, etc. So I want to find out the price, the average price per decade. So I'm using a let's take a look. So I'm printing the decade, I'm calculating the average price. So this is part of the select list. Let's move it just over here. Copy and paste made it a bit hard to read. So I'm basically using a group by expression. I'm grouping my movies based on the decade, and then I calculate the average price. And again, because our collection has more than just movies, I'm limiting this calculation to the movies. Here I'm using the where clause, and now you see that the average price per decade. I mean, I think this data has been randomly generated, so there is not much to be derived here in information. But if this was your real data, you could maybe identify that older movies sell better than newer ones. or similar things. So the message is that yes, you can run your analytical queries over JSON as well. Good. So now we have nested arrays. So now it's saying my internet connection is unstable. I hope you can still hear me.
Yes, yes, we can hear you.
Perfect. So another way to access your data is to use this nested path, or this nested syntax, and this will get a bit clearer here. But what I can do is I can extract all the values I'm interested in directly in the from clause. So I'm selecting from my products table, and then I say nested JSON document. So this is access my JSON document and project out these columns. I'm interested in the ID, the title, and the year, and I can optionally specify the data type, the SQL data type for this. So here I can say I want the year to be a number, and for title and ID, the default would be chosen to be a varchar value. So now this is not really unnesting any arrays inside, it's just fetching values from the JSON document. But what I can do is I can recursively use this nested clause. So every movie has an actor. So what I do here is, this is an addition to the previous query where I said I had the ID, the title, and the year. And now I'm basically recursively using the same mechanism of nesting, and I'm accessing an array. I'm saying go to my array called starring, and the square bracket star means select all the actors. So starring is the name for the array that has the actor names. And I want to, here I want a column called actor, and the path is just the value itself. This is what the dollar stands for. So this is kind of a variable name on, and I could further navigate down. So if this was an object, I could say $.a.b. But here I don't want to navigate. I just want to access the entire value from inside that array. So this is why I write it this way. And the result is now, and let's go look back at the JSON. So here, how does it look like? So you have your ID, you have your decade or year, you have your price, and here you have starring, and you see starring, it's a nested array with the actor names inside. And this is what we are unnesting here. So what you see is for this movie, Django Unchained, it actually has two actors. I guess there are more than two actors in the movie, but just two are stars. And this is why they are being returned as different rows, and all the values that apply to the same movie are getting repeated because it's still the same movie. So it's Django Unchanged and the ID, but now the actors have been unnested. So now I could do queries directly on actors, for example. I basically brought that information in the same form as if I would have stored it relationally. But here it's really just a view on the data. Nothing has changed in the way on how I store it. Good. Yeah, so it's also possible to, this is just a shortcut. If I'm not interested in the outer values, I could shorten this. I could just go directly to this starring array. So here you see products is the table. I go to my JSON document, but then I already go further to this array, and this way I can get all my actor names out of it. But now I'm basically going straight to this array of actor names and not selecting anything outside. Good. Okay. So what's this query doing? Okay. Let's run this query. Okay, starring, goodbye actor. Okay, so this is a count, like how many movies do we have, or this is a count of actors per movie. So we are same query as before. We're just unnesting these actors, but then I group them by the actor name and I count it and order it in a descending order. So I know that Robert De Niro plays in most of our movies, followed by Tom Hanks and Harrison Ford. So just very simple to use a analytical query over JSON here. So good. Okay, this is now introducing you to any questions so far before I go on to the next step here.
We've had one question about partitioning. Is it possible to use a relational partitioning mechanism, brackets data affinity? I assume that means on Soda Collections.
You can use partitioning. So you can either partition directly on a value from inside the JSON. So you could partition, let's say, by decade. It's also possible. So what we've shown here is really the collection way. So here you see there is a table called products, and it has these fields. One of them is the JSON document, and it has been created automatically when we created a new collection. So if I create a new collection here, test 1, 2, 3, create, now it says there is this collection, and if I go back and reload it, that table has been automatically created with a JSON type or JSON column. I could also create my own table using regular create table statement with arbitrary columns, and one of them or multiple of them being a JSON column. And then I could also partition on a relational column. So I can really choose how much JSON I want to have and how much relational I want to preserve. So this workshop is really showing the Soda collections and how to query it, but most or a lot of our customers are really adding JSON to existing tables. So they have kind of hybrid use cases where some information is stored relationally in a column, some others is inside a JSON. And then, yes, you can use partitioning for these use cases, and that is used quite a bit. Okay, I hope that answered the question. Good, and with this we go to a new way, or these Sql Json operators. So I can also fetch values from inside my JSON, not using this simple dot notation. So earlier I said you can go there and just use these dots like dot title or dot type. So they were fine for most use cases, but sometimes you want to have more control over the values. And this is where you get specific new Sql Json operators like JSON value, for example. So we're feeding it our JSON data. There is now a path expression. Again, we've seen this before, that there is this dollar, and here we say $.format. This just means this is my document root, go to the format field, and I want now even return this as a varchar 210, so I have very fine control over the return type, and I could even say what to return if I haven't found it. So for example, we say, we know that not everything is a movie, but there are some books in there, so they don't have a format clause. So for those, instead of null, we want to return none. So if I run this, you see here, whatever this was, it was not a movie, there was no format, so it says none for this value. So this is JSON value. And there is JSON value. Let's scroll back. I scrolled up. Now I have to go back. Yeah, this was the JSON value. I can also select values from the array. Okay, yeah, this is now to explain how JSON value works. So exactly. So let's, I think time-wise, let me skip this. This is all very well explained. I don't have to go too much into detail. Ettore, how much time is left? 15 minutes, is that correct?
Yeah, exactly.
Yeah. So there was a question how to extract fragments. I suggest you go into the JSON query part. We could quickly, oh no, I'm just, for time reasons, I skip this. This is all very well explained. We also cover updates, how to do JSON updates. Maybe we could run one version here, like JSON transform. Yeah, so this is one example. For example, where we could do an update using JSON transform. So this is again something you would need to do this in SQL. For now, we have not exposed that in Soda here. So SQL is the way to go. So there is a transform operator, and the way it works is you can do one or multiple modifying operations. So what we do here is we select from a movie with the ID, or we want to update a movie with the ID 515, and we want to add a new field called duration, and we want to increase the price by 10%, and we want to append Thriller to the array. So let's quickly select this guy here. 515, I guess. Oh, yeah, it should be on the product collection, not on the test collection. So let's see which movie this is. Oh, it's the Terminator. Okay, let's do an update. Okay, and let's reload it. So you see the genres, we have 2 genres, and now if we update it, we've added, I think, Thriller to it, the price has gone up, and there is this duration field being added. So yes, you can do updates. There is also, this is quite interesting, to generate data. So let me explain you this for a second. So as I said, you can generate, even in this autonomous cloud service, you can generate plain relational tables. So here we're creating one called emp, and it has 3 relational fields. So there is no JSON here at all. And I'm inserting 3 rows. Okay, so it's just in one at a time, I guess. Okay. And I have operators to convert rows into JSON. So I could say JSON object of all these fields, and now the information that was stored in the table is being converted into JSON. So this is another interesting part I recommend you look into. There's different ways on how you can generate data. Let's see, 10 more minutes. Yes, there's also like a bigger example here. Let's just run the outcome of it. This is just showing the strength of what you can do in SQL. So it's a longer statement, but what it basically does, it is converting the data, or it's giving you another view of the data. So what we store here is basically movies that have array on actors. And maybe we realize after a while, people really want to look up a movie based on an actor. So we need kind of a different representation of the data where we have actors with arrays of the movies that they act in. And this is what we do in this simple query, where we first extract all the actor names. I've shown that before. Then we create all the distinct actors because we only want to see every actors once. And then we generate a new JSON object with our actor name, which is now distinct. We only have one. And then we generate a field called movies, which is an array of all the movies they act in or that they play in. And what you see here is, for example, every actor name, and then there is an array of all the movies that they act in. So this is really a way to pivot your data. So this is the part on JSON. Where's my, this is odd scrolling. Why don't I, oh, here. And JSON, and there is a section on JSON data guide. This is which gives you a schema representation of your data. So I recommend, so the entire lab takes about like 90 minutes, and because I gave you this introduction, I think this end here, you can complete this by yourself. You still have some time to reach out. Let me just go back to these slides. and I briefly want to conclude this. So one question on this cloud service is in terms of performance, aren't relational databases slower than NoSQL databases, for example? And there was an analysis done last year by Wikibon where they tested like MongoDB cloud services, Amazon Web Service cloud service, and Oracle cloud service, the autonomous JSON, and they found us to be about 2x or a bit more faster. So we kind of get the better performance than NoSQL databases, while at the same time, you have all the abilities to joins and transactions, etc. So it's really a very appealing offering that we have. And this is kind of the summary or the messaging. So we are able to store JSON in our database. On the left side, we give you this simple access, puts and gets with JSON documents inside a collection. And here's also the languages that we support. And at the same time, you get SQL access over the very same data. So an application developer could use Soda to write their application, and then someone else could do reporting, analytic, machine learning over the same data, or they make updates on the relational or updates on the data, and it becomes immediately visible in Soda. So there is no need to use different databases if you want to combine relational and document store APIs. Good. I think I skipped this part on common use cases. I think that was covered before. This is an interesting use case on generation, which I skipped in the lab a bit or made quite short. So let me at least give you a use case. This was a customer that approached us. They had a lot of relational data. This was like a legacy system of their customers. They wanted to get a modern microservice-based architecture on top. So they wanted to view this data as JSON. And they started out writing their own Java code that fetched data from the tables, converted it into JSON, put it on a messaging bus, and that was inserted into a NoSQL database. And then they could get a read-only access to that NoSQL database to fetch the JSON. And this solution had multiple problems. I mean, beyond just being a lot of different moving parts that needed to be maintained. One problem was that it took up to like a minute or two before a change in the relational source of truth became visible in the JSON. So instead, all we did is replaced their Java code with simple SQL statements that generated. It's all done in the same database now. It can all be served from the same REST service. So it's a huge simplification, and it's also now really consistent JSON views over your relational data. No more staleness of a minute or two. Good. We're almost done here. Thanks a lot for staying on so long. So this lab was focused on this cloud service, but everything we've shown here is also possible on-premise. So Oracle's been supporting JSON for a long time now. 19C is now our long-term release. There is Oracle 21C coming very soon. That's an innovation release, so that would give you access to JSON type.
Peter, is there anything that people need to do to use ORDS in a 19C on-premise database?
They need to install
not ORDS,
right?
REST. Sorry.
They need to
Soda.
install ORDS, right? Soda,
yeah.
Yes. So you don't get this packaging that we have in the cloud. Instead, you need to download and install ORDS to get Soda. Or if you're not using REST, you can download the drivers for your programming language. So there's like these instant clients, which have support for Node.js and Python. And there is JDBC, I believe, if you want to use, or there's a Java driver for Soda if you want to use Java.
And of course, PL SQL.
And PL SQL, yeah. That's right.
So if you're using those APIs, then you don't need ORDS. It's only to support the REST capabilities that you need ORDS. Is that correct?
Say again?
If you're using those drivers, PL SQL, Node.js, etc., then you don't need ORDS. You only need ORDS to support the REST.
You only need ORDS for REST. So if you don't need to use REST, then you don't need ORDS. I wouldn't call PL SQL the driver because it's all happening in the database. So there's PL SQL support for JSON and for Soda. So this presentation today here really just covered some aspects of the JSON support that has been grown quite a bit. But But did you put like the link to the Soda starting page somewhere in the chat? Then
I did, yes.
Then this also points to what you need to do to connect to an on-premise database. And with this, I thank a lot, and I give it back to Ettore.
Thank you. So really, Beda and Roger, thank you so much. But of course, I want to thank you, the guests that are today with us. Really, we have a good average that is spending all the time with us. Here, a bit of information. Of course, one of the requests that I'm putting also into the chat is about the feedback. Please give your feedback about the session of today. You will get, once you close the Zoom session, also the redirect link to the survey. So please do it. You can be in touch with Beda if you need to write some question. I advise to follow him also on Twitter, and especially the blog, where you can get new insight. This one is part of this session. This DevLab is part of a program of masterclass that we are running for our region, Europe, Middle East, and Africa. The next one will be in the 22nd of July on Apex and JavaScript. So if you can go ahead, Beda, please. And then the last spot, let's say, it's about our main event. So this is the Developer Live event that we are going to perform on the 5th of August. Here you will have really a full agenda, one-day agenda. There will be a keynote, a panel, 8 talks, and 4 live hands-on lab like this one of today. I really hope that you can have a look at the agenda. You will have really a series of content that, of course, are related to probably some of the projects that you are following. There will be serverless, Kubernetes, how to structure an e-commerce, artificial intelligence. So I think that you will always find a good let's say, topic to join the event. So take a look at the agenda and register. Please, next slide. And last but not least, related to this event and all the modern app dev masterclass that we are performing, after the event, you have the possibility to get a quiz about the content that we had today, and you can get this digital badge for buds, and you can enjoy taking the quiz. For my side is everything. There are some questions still open into the Q&A box, Beda. So probably before to close, if you want to have a look, then we can really say goodbye because we are on top of our time.
Yeah, there's one question from Judith. Can we download the lab guide as PDF? I think you could. Yeah, I don't know. What if I don't think we have PDFs for this. You could.
No, it's not a PDF. You can get, so you have this web browser guide.
I mean, you could probably print it. If you just click on print, you could convert it to a PDF. I haven't done it. I don't know how well it looks.
On Mac, yes, I did. So it's working like that, I think.
Right. There's one question from Christoph on how about ORMs, so object relational mappers. I'm not going to answer this now. I would just say stay tuned. We have something in the pipeline for this. That is something that's coming quite soon. So just stay in touch with us. And I think those are all the questions that I'm seeing here. So thanks everyone for attending. Thanks Roger and you, Ettore, for moderating and answering all the questions. So this was great.
Thank you guys. See you and stay safe, of course. Bye. Ciao.
Bye.
Bye.